we're going to talk about place value in a little bit more depth. And to do that, we're going to compare our place value system, which is a base 10 system, to other systems that might be a different base. So let me explain what our base 10 means to start with. You might have seen these little unit cubes before. Each cube represents 1. So we have 10 single digits in our base system. And you can look at your calculator to see those digits. They're the numbers 0 through 9 are our single digits. After we get to the number 9, we have to put 2 of these together to make a 2-digit number. So 10 is a 2-digit number. 15 is also a 2-digit number. So the number 15, we have a number in the ones place and we have a number in the tens place. So if I were going to represent 15 with these unit blocks, this has 10 blocks in it. We call it a rod. So 1 rod and 1, 2, 3, 4, 5 ones. So 1 rod and 5 ones would be 15. And I could keep growing from here. Let's say I've got the number 215. This is called the hundreds place. Now the 10 is 10 to the first. 100 is 10 squared, the hundreds place. The next place value is 10 cubed. That's the thousands place. And then we would have 10,000s, and then we would have, and that would be 10 to the 4th and 10 to the 5th. We are using tens because we have 10 single digits because we are in base 10. The numbers 0 through 9 are 10 single digits. I'm going to change that now. We are no longer going to be in base 10. We are going to be in base 5. To be in base 5 means we only have 5 single digits, the first 5 single digits we see. So 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. Those are the only single digits I have. I cannot use any other single digits. So that is going to look like this. We have 0, then I have 1 item, then I have 2 items, then 3, and then 4. When I go to put my 5th one on, because I'm in base 5, that is now what 1 rod is. A rod used to be 10 because we were in base 10. Now I'm saying a rod is has 5 in it. So my next number is going to have 1 rod and 0 ones. I know that looks like the number 10, but I am not saying it's 10. I'm saying it's one of these and no empties. Next, I would have 1 rod and 1 1. That's not the number 11. That represents this many. 1 rod and 1 1 is how much that represents because a rod now only has 5. And then I could keep going. I would have 1 rod, 2 ones, 1 rod, 3 ones, 1 rod, 4 ones. So I'm up to this point. 1 rod has 5 in it, and then these 4 single. When I go to put the next single on, now I have 2 full rods. So that would be 2 rods, no ones. This is how we count in base 5. We have 5 single digits. After that, after those 5 single digits, we have to start putting those digits together to make 2-digit numbers. We're reusing symbols, so it looks like the number 10, but it's not really. It is 1 rod and 0 ones. It's hard to see that one. There we go. Point out one last thing, and I'm going to do another one. These are the beginning bases. If you are asked to find the natural numbers, remember natural numbers start with 1. So if you're asked to find natural numbers, don't include 0. You still don't add a 5 to it because we can't have that. 1, 2, 3, 4, 1, 0. So if I were asked to put out the first 6 counting numbers in base 5, it would be 1, 2, 3, 4, 1, 0, and then 1, 1. Right, so if you're asked about counting numbers, you start with that 1. If you're asked, if it doesn't say, if it just says digits, we could start with 0. All right, let's look at another one. You might have to skip ahead in your notes to write this one down. So go ahead and skip the problems. I'm going to come back to those. And we want to look at base 2. Base 2 is a computer system based. Computer programmings are based off this base 2. We basically tell a computer either do this or don't do this. Have it on or off. And that's because base 2 just has 2 digits. Again, it's 2. That's how I know it only has 2 digits. So it only has 0 or 1. Those are the only 2 digits we can use. So that means a rod is really, really tiny. It only has 2 blocks in it now. So when I start, I've got 0, 1. Next, I have 1 rod, 0 ones. Then I have 1 rod, 1 1. Once I put another block on, I have 2 rods, but I can't write 2, so I've got to go up to a 3-digit number. We actually call this a flat. A flat is a square, and this is a 2 by 2. Next, I would have a flat, no rods, and a 1. I'm just going to keep going for a little bit longer with these, so you can kind of see a little bit of maybe a little bit of a pattern. Next, I would have 1 flat, 1 rod, 0 ones. So I've got my flat, it's a 2 by 2. I've got my rod. Next, I would have 1 flat, 1 rod, and 1 1. So I've got my flat, my rod, my single 1. Now notice, these are all 3-digit numbers, and they are in order that we would think they are. They're the only 3-digit numbers that use 1 and 0. There isn't another way to write a 3-digit number that uses 1 and 0, because this is not a 3-digit number. That's the same thing as 1. That's the only way I write 3 digits. So that means next, I'm going to have to go up to a 4-digit number. We call those guys cubes here. This is a 10-block cube. It's 10 by 10 by 10. The length, width, and height are all 10. It's a little bit hard to do that. Here we go. There is 1 cube there. It's a 2 by 2 by 2. It's a 2 by 2 by 2. So there are 2, 4, 6, 8 blocks here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. That thing that looks like 1,000, 1 cube, 0 rods, 0 flat, 0 rods, 0 ones, is the 8th number in the list. Again, 1, 2, 3, 4, 5, 6, 7, 8. And there are 8 in here. 2, 4, 6, 8. Again, if you're asked about the counting numbers, don't include 0. Counting numbers start with 1. If you need to rewind and back up through any of these, definitely do it. Normally in a face-to-face class, I have lots of questions and I just need to re-say some things, which is totally fine. You can do that in rewinding. For some people, base 12 actually makes more sense. For other people, it doesn't. It's a little warning there, kind of hit or miss. Think about, in base 12, think about a dozen. Like when you go to the store, you buy a dozen eggs. That is 1 carton of eggs. So instead of having 10 in a rod, we have 12. So 12 eggs, a dozen eggs. That means we need to have 12 single digits. And this is where people don't like it. Some people do. Can't fit them all in there. Next would be 9. I cannot write 1 0 because that's not a single digit. I have to use a single symbol to represent 10 items. So to represent this many items, I have to use a single letter or single symbol, and I'm going to use the letter T. Then I need the same thing for 11. I need a single symbol to represent 11. I'm going to use the letter E. because I know that's what my math lab uses. But technically, we could use any of these, any symbol that you wanted to. Now, when I put the 12th one on, I have 1 dozen. So that is 1 dozen eggs and no single eggs. So a dozen eggs and none left over. This is 1 egg carton. I know that's number 10. You say, well, you put T there, but right now it doesn't represent 10. It represents 1 dozen and no extras. Then I'm going to have 1 dozen eggs and then 1 little egg left over. Then 1 dozen eggs and 2 little eggs left over. And I could keep going, adding 1 extra egg each time. Just want to get a few of them up here. So I could have, after I have 1 dozen eggs and 9 singles, then I have 1 dozen egg and 10 singles. Then 1 dozen egg and 11 singles, and then I have 2 dozen eggs and no singles. Remember, 2 dozen is 2 times 12, which is 24. And if I were to count this, this is going to be the 24th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Because 2 dozen represents 24. We're going to get some practice with going back and forth between the bases, but this hopefully gives you an outline of each type of the base. Feel free to rewind as much as you need to, and also email with any questions you have.